Look at this block of code. Isn't it beautiful? Don't you wish all your code could look like this? Yeah, me neither. As it is now, this store data function isn't terrible. There are only two possible storage locations and the code is quite short. What happens if we want to store our data somewhere else? If we wanted to add a local disk storage method, we'd not only have to add another function to deal with that, but we'd have to add another branch to this if statement. And this is just the put function. You'd have to repeat all of that if you wanted to be able to retrieve your data too. It's also really easy to pass in the wrong string here, so we could be woken at 3 AM by angry customers who have no idea why their data isn't where they expect it. So how do we solve this? One way is to use the strategy pattern. Don't know what that is? That's not a problem. I'm about to show you what the strategy pattern is, why it's so powerful, and rewrite this hideous code to use something much nicer. At the end of the video, I'll also go into detail on how to use single method interfaces to create truly powerful abstractions. The strategy pattern is a design pattern that allows you to cleanly separate different algorithms and behaviors into separate classes. Each algorithm implements a common interface, so you can easily switch between them at runtime without having to modify your core code. By using the strategy pattern, you can make your Python code more modular, extensible, and easy to maintain. Of course, it's not without its drawbacks, but let's get into the refactor and we'll go over those in more detail later. Here's the full code snippet from the example earlier. In this main file, we have two data storage functions and a simple data pipeline. The put and get functions contain the if-else statements you saw earlier and currently have support for Amazon S3 and MongoDB as data storage locations. We also have two modules with our put and get functions specific to S3 and MongoDB. They don't actually do anything, but just print out when they're called so we can see what's going on. The data pipeline takes a data storage method and key as parameters, gets some data with the key, does some calculations with this data, and then stores the results with a new key, which is then returned. It's not pretty, and if I wanted to add a new storage method like JSON storage, not only would I have to write the code to do the storage, but I would have to update the main put and get functions too. Another problem that gets highlighted in the MongoDB example is credential storage and connections. In the MongoDB get and put methods, I'm having to get my MongoDB credentials and create a new connection every time I want to perform an operation. In our example, we only do two calls to the storage location, but a real-world data pipeline could make hundreds or even thousands, and creating new connections each time would be expensive. So, how do we refactor this to use the strategy pattern? Well, we're going to use Python's protocol type hint. Protocol is like an interface in other languages. It allows you to define the methods an object should have without knowing the implementation details up front. We'll start our refactor by defining a data store class that inherits from protocol. Here, we'll define our put and get methods and the types that they require and return. You'll notice that we're just passing in the body of the function. We only need to define the function signature here. Business logic will be taken care of in classes that implement this protocol. Next, we'll refactor our S3 and MongoDB code into classes. Notice that our storage methods have the same signature as those defined in the protocol. This means that these classes automatically implement our protocol, and we're not having to explicitly tell Python that S3 storage is a data store. In the MongoDB case, we can also define an initializer method that stores our credentials as instance properties, along with a single connection that will last for the lifetime of any instances of the class. This means the connection can be used multiple times. Back in main.py, we can change our pipeline function to take an instance of data store as the storage method, and instead of calling our original functions with the storage type as the first argument, we can simply call the methods on our data store. Finally, we can remove our original put and get functions and update our main function, creating new instances of our S3 storage and Mongo storage classes and passing them into the pipeline function. If I run the code now, you can see that it behaves exactly the same as before. Let's now add the JSON storage method I mentioned earlier. All we have to do is add a new class that implements the data store protocol, like I've done here. Now, we can import this into our main function, and all we have to do is call the pipeline with a JSON storage object, and we can now use JSON storage, which is great for local debugging. So, why would you do this? Well, of course you get the cleaner code, but there are other reasons to opt for the strategy pattern. One major benefit is that you can easily change a pattern at runtime without lots of conditional statements everywhere. Imagine you're running an e-commerce store and you want to give members a different price depending on their membership tier. You could create a pricing strategy protocol and have different versions for your different tiers, allowing you to have infinitely complex pricing models really easily. Do you know what else is easy? Subscribing to my channel and liking this video, of course. You may be wondering why you might pick Python's protocol over using an abstract base class, or ABC. Unlike ABCs, protocols are duck-typed, meaning you don't have to explicitly inherit from them in order to implement them. This is great when you have an external library that has an object with the same methods as defined by your protocol, because you can swap in that object for yours without having to wrap it in a new class or make changes to that library. However, protocols don't currently allow you to define properties and class methods, so you'll need to use an ABC for those. ABCs are also checked at runtime, whereas protocol classes aren't. They're mostly a tool to help at write time, and your editor's typing features should help you pick up on that. I want to take the last few minutes of this video to talk about single method interfaces. The interface in the earlier example had two methods, get and put, but what if we split this up further into two protocols, data source and data sink? We'll also edit our pipeline function to take in a source and a sink. The nice thing about this change is we don't have to change any of the actual infrastructure logic, just the pipeline and main functions, as our existing storage classes already implement both of the protocols. Since our data sources and sinks are now separate, we can also pipe data from one location to another. For example, I've been able to quickly set up a pipeline that reads from JSON and outputs to S3. However, if you think about it carefully, you'll notice that there's another class that implements the data source protocol. Have you spotted it? That's right, Python's built-in dictionary has a get method that has exactly the same function signature. Because protocols are duck-typed, a dict object is a valid data source, so we can happily use it in our pipeline function. This is the power of the single method interface. It allows you to write modular, extensible, and flexible code that's easily testable and very readable. You'll see this pattern used a lot, particularly in languages like Go, where the standard library has single method interfaces like io.writer and io.reader. The truly powerful thing here is that these interfaces are used by the standard library. So if you implement a read method on your struct, you can use it in standard library functions without having to do any manual type conversions. The strategy pattern is incredibly powerful, and I hope I've convinced you of that in this video. Be sure to use it where appropriate, but remember, it's only part of your Python toolkit. If you use it everywhere, your code will be just as confusing and difficult to follow as this. If you've enjoyed this video, I used the strategy pattern in my video about whether you should use object-oriented or functional programming in Python, which you can find here.